Yes, time travel is possible into the future. A fundamental result in Einstein's theory of special relativity that he wrote down in 1905, the one from which E equals mc squared emerges, his most famous equation, is that moving clocks run slow. So quite specifically, if you're sat there in your room now where you're listening to this broadcast, or imagine us sat here, and imagine a clock flying past us, then that clock would run slow relative to us. It's not just we'd see it run slow, it would run slow relative to us. So that means that if I were to fly off now, let's say I flew off to Alpha Centauri, the closest star, or the Andromeda Galaxy, over 2 million light years away, and I flew off very close to the speed of light, and I came back again, then you would have aged far more than I would. In fact, thousands of years could have passed on Earth in the time that it took me to do my little journey.
Imagine you have a light clock with you. This light clock has two mirrors in the opposite directions and a light beam bouncing between them. Now, let's say the distance between the two mirrors is d, and the time for the light to cover that distance is t. For the sake of simplicity, let's say it's 1 second. So, when this clock is with you at rest position, the light bounces between the mirrors, covering distance d in 1 second, which gives us the speed of light s. Now remember, speed is distance per unit time. Now consider Einstein also possesses the same light clock with him. Only this time, he's traveling in a spaceship along with the clock. When Einstein travels in a certain speed, the clock travels with the same speed of the spaceship in the same direction. Here, light has to travel an extra distance in the same 1 second. Let's consider this distance to be capital D and represent the speed of light here as capital S, which has to be greater than small s. But something's wrong here. Because in the late 1800s, the Michelson-Morley experiment tried to detect the relative motion of the matter through an ether and concluded that the speed of light is constant. This cosmic speed limit is known as c. So in our little scenario, small s and capital S are equal. So for the speed of light for both you and Einstein to remain constant, something has to give way. That something is time. It turns out, time slows down when you travel faster and faster, nearing the speed of light. So the faster Einstein travels, slower the time passes for him. Hence, what could be a day for Einstein in space could be as much as 50 years for you on the ground.